Now, Kirchoff's laws for circuits give a mathematical description to what happens to currents and voltages in a circuit. Kirchoff's first law looks at currents. If we have a current of I total coming in from the left on that single wire, and it comes to a junction of 3 other wires, it'll split into 3 currents, I1, I2, and I3. What Kirchoff's first law says is that all the current flowing into a junction or a point in a circuit equals all the currents flowing out of that point. This is simply saying that charge is not created or destroyed. Mathematically, we write that down as that I total is equal to I1 plus I2 plus I3. Kirchoff's second law looks at what happens when you go through a loop circuit. It says the sum of all the voltage sources and all the voltage drops across resistors around a loop is equal to 0. This is conservation of energy. We start and end at the same point, so we should have the same energy when we get to that point. So if we write it down mathematically, we have V0, which is our voltage source in this little circuit, minus the voltage drop IR across that resistor, and that should be equal to 0, which is Kirchoff's second law for this simple circuit. Let's look at a couple examples. In the first one, we have 2 identical resistors that are hooked up in 2 different ways. The same current flows into the points A. Is the current the same throughout both circuits? That's the question. In the series circuit, there's only one path from point A to point B, so the current is the same throughout. So we would just have a current of I in both resistors. Current in the parallel circuit is not the same everywhere. There are 2 paths, an upper and a lower path, so that the current splits between the upper and lower paths. Because they're identical resistors, you have I over 2 in the upper path and I over 2 in the lower path. You can think of this as like a river encountering an island. The current will split to go around the island, so you have some going left, some going right, but later they'll come back together to form the main channel again. So we have the current, so we have I originally splitting into I over 2 on either side of the island, and coming back together to being I at point B. In the second example, we have a battery and 2 identical resistors that are hooked up as shown. There are 2 questions we want to answer. What is the current through the circuit? And what is the voltage drop VAB, which is equal to VA minus VB across the second resistor? There's only one path around this loop, so there's only one current. We'll call that I. Then we use Kirchoff's second law, and we write down all the voltages and all the voltage drops. So we have our voltage source minus the voltage drop due to the first resistor, minus the voltage drop due to the second resistor, and that's equal to 0. We solve that for I, so I is equal to V0 divided by 2R. So that is the answer to our first question. What is the current through the circuit? Now to answer the second question, what is the voltage between VA and VB? We look at Ohm's law and write down VAB is equal to IR. We can then we know what I is from we found that just above. We can bring that down, and then we multiply by R, and then the R's cancel, and that leaves us that the answer is V0 divided by 2. So the voltage across the second resistor is half the voltage of the battery.